Hi, and welcome to the Unit 1, Day 3 review video for Honors Chemistry. So in this unit, we're learning about atoms and nuclear chemistry. And we started by taking a look at atoms, knowing what they're made of, the three subatomic particles, and the parts of the atom. We also looked at the evolution of the atomic model. And now we're moving into representations of atoms. So there are three representations of atom that we're going to use most in this class. You have the Bohr model, nuclear symbol, which is what we've talked about today, and later you're going to find out about the isotope name. And basically, these three representations are ways of describing or depicting an atom. And the thing about all three representations is that they tell you the same thing. They all tell you the number of subatomic particles, the number of protons, neutrons, and electrons, and the characteristics of the atom. So remember, the characteristics will be the mass number, which describes the mass or how heavy the atom is, the atomic number, which identifies the atom, and the charge, which tells you whether the atom is positive, negative, or neutral. Now, even though all of these representations tell you that information, sometimes you can get the information directly. For example, if you look at the Bohr model, and if you want to know the number of protons, neutrons, and electrons, all you have to do is just look at it. So here it tells you have 6 protons, you've got 8 neutrons, and for the electrons, you would just count the dots in the electron shells. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so you got 8 electrons. So sometimes you can get it directly. And other times you're going to need to figure it out. So if you look at the nuclear symbol here, the nuclear symbol has 3 numbers, and of course the symbol for the element in the middle. The upper left number is your mass number, the lower right is your atomic number. The lower left is your atomic number, and the upper right is your charge. So we can't tell by looking at this directly what the number of protons, neutrons, and electrons are, like we did here. We have to figure it out. So to figure it out, for protons, you have to figure out which of these numbers are you going to use. And for protons, it's just the atomic number, because the protons are equal to the atomic number. So we know by looking at this has 6 protons. When it comes down to the number of neutrons, you have to use the mass number and the atomic number. Because remember, the mass number is protons plus neutrons. So you're going to need these two pieces of information to get the neutrons. And you would just subtract these two numbers. And if you did that 14 minus 6, that will give you 8 neutrons. And finally, for the charge, you're going to use these two pieces of information. And a lot of times I like to use mental math for this. You can use an equation if you want. But using these two pieces of information, since the overall charge is negative, I know I'm going to have more electrons than I have protons, and I'm going to have 2 additional electrons. So that will be a total of 8 electrons. So as you see here, I had to figure that out figuring out which numbers to use and how to use them. All right, so let's take a look at the examples that we went over in class today. In this first example, you were asked to write the symbol for given this Bohr model. So you have a Bohr model. What's the nuclear symbol? All right, so the first thing that we did was we looked for the we looked at the atomic number. And remember, for the atomic number, it's the same as the number of protons. So the number of protons is the atomic number. So I'm just going to take the number of protons and put it here. So 17 goes here. All right, so that's cool. All right, what else? What about the mass number? So for the mass number, remember, it's the protons plus the neutrons. So let's take a step back. When you're calculating the mass number, why do you only use protons and neutrons? Remember that the mass number, which describes how heavy it is the addition of protons and neutrons, because if you look at the subatomic particle summary chart, we know that protons have a mass of about 1 AMU, neutrons have a mass of about 1 AMU, but electrons have essentially no mass. Their mass is so tiny, it doesn't contribute much. So if you wanted to know the overall mass of the atom, which of these do you need to know? Just the protons and neutrons, because they're the only ones that have mass. So you're just going to add those two together to get the mass number. So in this case, we would add 17 and 18, which would give us a mass number of 35. That means that this atom weighs approximately 35 AMUs. And just to remind you, an AMU is an atomic mass unit. It's a unit of mass, just like grams, but it's much smaller than grams. Okay, so we've got our mass number, we've got our atomic number. What about the symbol that goes in the middle? For that, you need to use the periodic table. Now remember on the periodic table, and I'm just going to grab my periodic table here. Each element has an atomic number, and in this periodic table, it's written at the top. The atomic number is the whole number. The decimal number, what's called the average atomic mass, which you'll learn about later. But for us, for right now, we're going to focus on the atomic number. Now, the atomic number, which is equal to the number of protons, is the identifying characteristic of the element. What do I mean by that? I mean, if you look at sodium, for example, it has an atomic number of 11. That means that if you have an atom that has 11 protons or an atomic number of 11, you know it's sodium, because all sodium atoms and only sodium atoms can have an atomic number of 11. So if we want to identify the atom, which of these numbers are we going to use? Are we going to use the mass number or the atomic number? That's right, we're going to use that bottom atomic number, number 17. So what we need to do is then take the bottom number, that atomic number, and look for it on the periodic table. And here it is. And I'll zoom in to show you that that is chlorine. And the symbol is C, capital C, lowercase l. Remember, for element symbols, you always start with a capital letter, and then the rest will be lowercase. All right, the last thing we need to check is the charge. So for the charge, we're going to go back to our subatomic particles. Which subatomic particles do we need for the charge? Well, let's think about that. If you look at the subatomic particles, protons have a positive 1 charge. Neutrons are neutral, and electrons have a negative 1 charge. So which of these are going to contribute to the overall charge of the atom? That's right, just protons and electrons, because those are the only ones with charges. So we're going to use that information to figure out what's the charge here. Now, in this Bohr model, and I sort of just take a step back. We saw from before that we have 17 protons, because that's what the P stands for. We have 18 neutrons, right? Just from the nucleus inside, it tells you. But for the electrons, you have to count the dots, which represent the electrons. Okay, so let's go ahead and count those. 2, 4, 6, 8, 10, 12, 14, 16, 17. So this has 17 electrons. Okay, so going back to our charge, remember we're trying to find the charge, and to find the charge you need to know the number of protons and electrons, because these are the only two subatomic particles that have a charge. Protons have a positive charge and electrons have a negative charge. And if we look at our atom, we have 17 protons and 17 electrons. Okay, so if this atom has 17 protons and 17 electrons, what do you think the overall charge is going to be? That's right, the overall charge will be 0 or neutral, because they cancel each other out. So if you have a proton and electron together, they cancel each other out, making an overall neutral charge. All right, so let's just sort of recap what we did here. In order to answer this question, the first thing you need to do is, if you want to write the nuclear symbol, the nuclear notation symbol, you need to know the number of protons, neutrons, and electrons. And that we have listed here, and we got that from the Bohr model. Then in your symbol, there are two numbers on the left-hand side. For the lower left number, that's the atomic number, you just use the number of protons. For the upper left number, which is the mass number, you add the protons and the neutrons. To get the symbol that goes in the middle, you use the atomic number and look on the periodic table for the element that has that atomic number. And then for the charge, you're going to use your protons and electrons, since those are the only two with charges. Okay, last video. The last thing we did was we worked backwards. Now we're given the symbol and we're trying to figure out protons, neutrons, and electrons from it. All right, so to do that, what we're going to do is let's start with the protons, because that's the easiest. Remember, the protons are equal to the atomic number. So to get the number of protons, look at that bottom left number. Now, what about the neutrons? Which of these numbers do we need? For the neutrons, you're going to use the mass number and the atomic number. So for the neutrons, you're going to look at the mass number and the atomic number. Now the mass number is the number of protons plus neutrons, and we know we have 15 protons. Our mass number here is 31. So I'm going to just sort of put my numbers in above. So 31 is the mass number. The number of protons is 15. And I need to add some neutrons to the 15 protons to get a mass number of 31. So I'm just mentally asking myself, 15 plus what will give me 31? If you wanted to solve this using some algebra skills, you would use the inverse operation of addition, which is subtraction, and it would be 31 minus 15. Either way, whether you use mental math or your algebra skills, you would get there's 16 neutrons, because 15 plus 16 will give you that 31. All right, the final number we need to look at are the electrons. So for the electrons, which of these numbers are we going to use? Remember that for the electrons, you're going to use both the charge and the atomic number. Okay, so we're going to use both the charge and the atomic number. All right, so the charge here is -3, and the atomic number is 15. How do we use those pieces of information? Well, remember the charge comes from combining protons and electrons. And if you have more protons than electrons, your overall charge will be positive. If you have the same number of protons and electrons, your overall charge will be negative. But if you have the same amount, then your overall charge will be 0. So let's look at our example here. We have a -3 charge. So what does that tell us? Do we have more protons or electrons? We definitely have more electrons. Remember, electrons are the negative things, the negative subatomic particles, and protons are positive. So if you have an overall negative charge, that means the electrons are dominating. You have more of them. Now, how many more electrons do we have? Well, if it's a -3 charge, that means we have 3 more electrons than we have protons. Well, we have 15 protons, so that must mean we have a total of 18 electrons. So I just wrote here, we have 3 more electrons than protons because the charge is -3. So just to sort of recap, when you're given the symbol and you're trying to figure out the number of protons, neutrons, and electrons, what you need to do is for each of the subatomic particles, figure out which of these characteristics or which of the numbers in the symbol do you need. For protons, you just use the atomic number. For the neutrons, you use the mass number and the atomic number. And for the electrons, you use the charge and the atomic number. All right, so the last thing I want to just sort of show you, last 2 things, is that when we're talking about all of these things, it's important to note that this representation, this is the same representation of that atom. So when we're looking at this, we should sort of visualize an atom that has in its nucleus 15 protons, 16 neutrons, and in the electron cloud or shells has 18 electrons, okay? So that's what this information, that's why this information is important. But it's hard to draw a Bohr model, so that's why we use the nuclear symbols. It's just easier. Okay. The last thing I want to show you is a sort of a trick that kids last year talked about. This is a trick for finding out the number of electrons from the charge and the atomic number. So sometimes instead of doing that mental work, oh, the charge is negative, that means I have 3 more electrons than protons. What you can do is a simple trick, and essentially what that means is just to flip the sign of the charge and then combine the charge with the atomic number. So in this case, for example, the charge is -3. And so what we're going to do is we're going to take our atomic number, which is 15, and since the charge is -3, we're going to do 15, and we're going to make it from a minus to a plus, so 15 plus 3. Okay, so that's how we would get the charge for that. If the charge was +3, then it will be 15 we would flip the positive to a minus sign, it would be 15 minus 3. So that's just sort of a trick. So if you want to use that trick, you flip the sign up in front of the charge and then combine it with the atomic number. So for example, if the sign of the charge is negative, you add the charge to the atomic number. If the sign of the charge is positive, you subtract the charge from the atomic number. All right, that's it for this video. I hope you found it helpful. If you have any more questions, just send me a message in Schoology. Have a quality day.